Alright, so if you're watching this video, it's to study for your Honors Math 2, Unit 2 Number and Quantity test. So again, I'm really sorry that I couldn't be with you guys there today at school to review, but if you watch this video, you should be prepared for your test. So for the first section, we're going to talk about rational, irrational, all of our number system problems. So for number one, if a number is a rational number, then it is a real number. If you think back to the anchor chart we had, there's real numbers and then there's imaginary. And a real number is any kind of number that we could envision or see on a number line. So rational numbers are real numbers. So that is always true. All right, for number two, if a number is positive, then it is an irrational number. So positive numbers, we need to see if there's a positive number that is not irrational to disprove this. So what about positive 2? Positive 2, is that irrational? No, positive 2 can be written as a ratio. So positive 2 is not irrational, but are there positive numbers that are irrational? Yes, so this is sometimes true. All right, number 3, if a number is an integer, then it is rational. So let's think about that. Your integers are your whole numbers that are negative or positive. We can add 0 in there too since it's a whole number. So all of these integers, can these be written as ratios? Yes, so this should be always true. All right, if a number is a repeating decimal, then it is an irrational number. So what do we know about repeating decimals? If I have 0.33 repeating, that can be written as 1/3. So repeating decimals can be written as ratios. So are they ever going to be irrational? No, so that should be never. And then for 5, if you add a rational plus an irrational number, you get a rational number. Well, if you remember your rules, we have rational plus rational is rational, and then we have rational plus irrational is irrational. So should we ever get a rational number? No, so that would be never. All right, so that's the first section you need to make sure you're prepared for on the test. Seeing statements like this where you have to determine if they're sometimes, always, and never true. And if you're watching these videos, I'm going to let you in on some secrets about your test. So make sure on your test you're able to come up with examples or explanations for why you chose sometimes, always, or never. So for the second section under this same topic, so we're still talking about our number system, we're going to determine if the following real numbers are rational or irrational and explain why. So 14 square root of 2, that would be irrational, and there's a couple of different explanations that you could probably think of to give for this, but the one that I'm going to be looking for tomorrow on your test is because 14 times the square root of 2 is a rational times an irrational, and if you know your rules, that automatically makes it irrational. Now, another reasoning, if you type in 14 square root of 2 in the calculator, you're going to get a decimal that goes on forever, doesn't repeat, and it has no pattern. So that is a non-terminating, non-repeating decimal, which automatically makes it irrational. So for number 8, we have 5.25 plus 2.333, and it says repeating. So we're going to pretend this is 2.3 repeating. I shouldn't say pretend, we're inferring because it says repeating. So I've got a rational plus a rational. Well, if you look up here at number 5, we just talked about how a rational plus a rational will always give you another rational. Another way you could check this is to add these two in your calculator. It will end up being 3 repeating on the end, which means it's a repeating decimal, which we know, as we talked about up here in number 4, is a fraction. So that is rational. All right, number 9, negative 8 pi. A lot of you are going to say irrational because there's a pi, but that's not a great explanation. Why does the pi make it irrational? because just because you see pi does not necessarily mean it'll be irrational. So if we do -8 times pi, that would be a rational times an irrational, which by our rules we know gives us irrational. Okay, for number 10, 6.122 is a rational number times the square root of 9. Please be careful here. The square root of 9 is equal to 3, which is also rational. And a rational times a rational should give us a rational. All right, for number 11, this ... right here indicates that this decimal is non-terminating, which means it goes on forever. And there is no repeater bar, so we can't assume there's a pattern. So that makes this first part irrational. And then times a rational. But we have to be careful here, because what is the rational number they gave us? 0. What is anything times 0 going to be? 0, which is rational. All right, so right here, if you're watching this video, I'm going to let you in on another tip. Right here, a rational times an irrational is irrational, except for when the rational number is 0, because we know anything times 0 is 0. And then we have a rational times a rational is another rational. So why do we not have an irrational times an irrational rule? Make sure you look back in your notes and you know that for your test tomorrow. Okay, lastly for number 12, square root of 6 is an irrational number. If you type it in, you're going to get a decimal that goes on forever and no pattern. And then the square root of 25 just equals 5. So we have an irrational plus a rational, which is going to give us an irrational by our rational irrational rules. So this is the first section of your test review on number sets, real numbers, rational numbers, that kind of thing. Make sure you study this and you watch this video for tips on your test tomorrow. I'm going to jump to the back of the review, number 38, because this is also talking about number sets. It's just not in order. So for number 38, it says given the domain -12 to +22. So I'm talking about any numbers from -12 to 22. It says A is the set of all odd numbers. So set A is going to be all odd numbers between -12 and 22. So that's -11, -9, -7, -5, -3, -1. Remember, 0 is not odd, it's even because it can be divided by 2. You still get 0. So 1, 3, 5, 7, 9, 11. I'm going to run out of room. And 21. Maybe not. All right. So there's set A, my set of all odd numbers. Then it says set B is the set of multiples of 4. Color code it for you guys. So set B is a set of multiples of 4. So for B, I want any number in between -12 and 22 that is a multiple of 4. So -12 is because 4 times -3 will give me -12. -8 is because that's 4 times -2. -4 is that's 4 times -1. 0, this is where you guys will mess up on the test tomorrow. 0 is a multiple of 4 because it's 4 times 0 gives you 0. Then we've got 4, 8, 12, 16, 20, and I'm going to stop because my domain only goes to 22. So these are my two sets. For A, it says find A union B. So set A union set B. So if you think back to when we did probability, and you guys just retested on probability, and most of you did really well, a union means it can be in A or B. So this is any number that is in A or B. All right, so if you look at set B and set A, it looks like they have nothing in common. So I literally would write out every single one of these numbers. So I am going to do that quickly for you guys. Remember, when you do a set, the numbers inside should be in ascending order, so smallest to largest. So we've got -12, -11, -9, I'm going to go ahead and cross through them as I use them. -7. Actually, I won't do that because I need to post a picture for you guys too. Y'all are lucky y'all got a good teacher. -5, -4, -3. Then we have 0. Nope, -1, Miss Poole. Then 0, 1, 3, 4, 5, 7, 8, 9, 11, 13. Oh, I forgot 12. 13, 15, 16, 17, 19, 20, and 21. All right, so that is the set that has any number that's in A or B. So remember, or means it just needs to be in at least one of them. It can be in one, it can be in both. As long as you see that number listed in these sets, it should go in the or section. So for the next part, when we're looking for A intersect B, part B, remember the upside down U is an intersection. That means I want any number in A or B where it overlaps, which means these are numbers that have to be in both A and B. Okay? So if you look at A and B, are there any numbers that they have in common? Okay. I don't see any, which means this set is just what? Nothing. So it's empty. So you can do an empty set. Make sure you don't put anything in it. 0 is a number. It's just empty. Or you can write it as no solution. That is also a symbol for the empty set when we're talking about number sets. All right, so for the last one, part C, we're finding A minus B, or the difference in A and B. So what I'm looking for are numbers that are in A. So remember, it has to be in A. So I am only looking at my bottom list. Numbers in A, and then any number that ends up in B, I'm taking out. So we're going to take out the numbers from A that are also in B. All right, so if you guys look at set A, we talked about this earlier on part B, but set B and set A have nothing in common. So if you're doing this on the test, I would make sure that you know how to take out the ones that the two sets have in common. You can go back and look at your homeworks and notes for this. Those examples should be really helpful, hint, hint. But for this one, A and B have nothing in common, so is there anything to subtract from A? No, so you would literally rewrite every single number that's in A. So I've got -11, 9, 7, 5, 3, 1, 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, and 21. So that would just be my answer for this one, set A, because there's nothing in common. So that's it for this section of the review. I'm going to go ahead and stop this video and then make sure you watch the next one, which will be on polynomial operations.